So thanks for being here. I'm Melissa Stewart. As Bryn said, I am a senior engineering consultant at Efficiency Vermont. I work primarily in decarbonization projects across commercial and industrial and a little bit residential, but mostly commercial industrial is my background, especially as pertains to refrigerants, which we're going to talk about more today. And my colleague Li Ling Young, who I think some of you know, is on the call. She'll be jumping in later to do the second half of this training. She has deep experience in the residential HVAC and decarbonization world. And this is one of our favorite topics. So we are just happy to be here with you today. So we are here to talk about climate-friendly heat pump design and installation, refrigerant stewardship in the age of electrification. And our hope is that by the end of this session, you will know what every word on that screen means and why it's there. So let's get going. Just to set the stage for our discussion today, here are some topics we're going to cover today in a few different ways. And we're going to touch on these things a few different times as we come along. We'll kind of go in one direction and come back for a minute and then go again, because it's this complicated feeling sometimes, interconnected web of ideas, but all of it will make sense, I hope, by the end of this. We're going to talk about refrigerant stewardship and what that term means. We're going to talk about policies that affect your business as an EEN contractor or associated interested person, and some practices and tools that relate to your day-to-day work. So first, what is refrigerant stewardship? What do I mean when I say that? Well, refrigerant stewardship is the responsible use and management of refrigerants from their manufacturer to their disposal. So keeping refrigerants inside their pipes and containers, recovering refrigerants and keeping track of them and dealing with them responsibly at the end of life. And as it says in the title of this presentation, refrigerant stewardship is really a key to climate-friendly installations of equipment like heat pumps that use these substances called refrigerants. And I'm going to get into what is a refrigerant? What do I even mean when I say refrigerant in just a minute? But I would guess that in this audience, most people are at least a little bit familiar with refrigerants and some of the issues that come up as you're installing and needing to deal with charging up new systems or topping up old systems that have leaked. So the refrigerant stewardship piece of heat pump installation is really important for the planet. But another great reason to pay attention to this whole topic is to improve your business, which is the purpose of the points on this slide here, because refrigerant stewardship can lead to faster installations, reduced maintenance callbacks, better customer satisfaction, and lower costs overall for both you and your customer. We're going to come back to these points in the second half of this presentation and get into specifics, but I'm hoping that this slide will pique your interest a little bit to sort of stick with me through this first half. So refrigerants. What are refrigerants anyway? Well, they are the working fluids in any kind of refrigeration cycle, including the ones inside heat pumps, that we use to move heat by exploiting the refrigerant's phase change properties, right? The closed refrigerant loop that cycles a fluid known as a refrigerant from vapor phase to liquid phase and back again through evaporation and condensation over and over again. And it carries heat with it and releases it where we want it to go. They are also HVAC's best frenemies, as we've written here. Best friends, because refrigerants are incredible. They're amazing, thermodynamically speaking. They allow us to have all these amazing technologies that we need for safety and comfort as humans. But they're enemies because the types that are most commonly used today are incredibly potent greenhouse gases. So they're speeding up climate change, which makes a lot of the world hotter, which means that more HVAC and refrigeration will be needed, right? And a feedback loop can kind of be created if we're not careful. The story of refrigerants in our sector isn't really a super simple one to tell. You can't tell it in one sentence. I've had friends and family ask me about refrigerants because they know it's like a thing that I'm super into at work, one of my specialties. But then they pretty quickly ask me to get to the point already to just kind of sum up. But you can't understand the American refrigerant situation without knowing a tiny bit about history and a tiny bit about chemistry. So while I promise I will do my best to get to the point as fast as I can, I first got to back up and talk about where we've been with refrigerants as a sector, where we're going, and what's next in the US, probably, since we don't actually know the future, unfortunately. Um, but we have a pretty good idea of where we're headed, as I'll get into a little more later. So as I said, to understand where we find ourselves today, we've got to talk about where we've been. We have had international, federal, and state regulations for these for a long time, and we are still on that journey as a sector. So the story of refrigerants in the United States starts way back in 1834 at the tail end of the Industrial Revolution with the invention of the vapor compression cycle, which was a huge breakthrough, technologically speaking, for us as an industrialized society, right? Possibilities of HVAC and refrigerators got opened up nearly 200 years ago, and the closed cycle vapor compression cycle was invented. And then around World War II, sort of the industrial explosion that happened in that period of time, we see the invention of synthetic refrigerants in the US by the largest chemical company in the country. And the first family of refrigerants that was invented were called hydrochlorofluorocarbons, or HCFCs, or CFCs, chlorofluorocarbons. There were CFCs came first, and then we had HCFCs, and I'm going to come back to that in a minute. But the reason that these synthetic refrigerants were developed was to deal with the safety issues of the fluids that were being used before that. The first refrigerants that were used in the first century of the life of vapor compression technology included some of the so-called natural refrigerants that we use now, that we still use, but also included some really nasty stuff that we wouldn't touch now. And also, it was a couple centuries ago, so we didn't have the robust system of safety certification and training and procedures to follow that we have now. So synthetic refrigerants were not flammable and were not toxic to humans. So they solved a problem. They made it easy for people to throw tanks of these things in the back of a truck and do what they needed to do without the technicians worrying much about the fluid itself. Then in 1987, we have the passage of the Montreal Protocol, which is an international treaty that was signed by a bunch of countries around the world, including the US, because scientists had realized in the couple of decades preceding that these synthetic refrigerants, CFCs and HCFCs, were eating up the atmosphere. They were eating up, they were making a hole in the ozone layer. And that is bad. We are humans. We need protection from radiation from space to live, and we need an environment. So in 1987, the world government, or a bunch of world governments, came together and said, we are going to phase out the use of these ozone munching fluids. And then in 1997, we see another international treaty arise, the Kyoto Protocol, which is where the world again came together to acknowledge the existence and seriousness of climate change as an issue, which it took a little while, but eventually led to, in 2016, the Kigali Amendment to the Montreal Protocol. There's not going to be a quiz. You don't have to remember all these dates and names. This is just to help you see this journey that we've been on with refrigerants in the HVAC sector for a while. So in 2016, there was another international treaty signed where the world agreed to start phasing out HFCs because scientists had again discovered a problem that they didn't know about before, which is that synthetic hydrofluorocarbon refrigerants are super potent, as they're called in some of the legislation, greenhouse gases. And then the most recent driver of change that we're seeing in the United States is called the American Innovation and Manufacturing Act, or AIM Act. It was passed by a bipartisan Congress in 2020 at the tail end of the previous administration to phase down the use of HFCs in the United States with some teeth behind it. It gave the EPA the job of doing that. So this is an approximation of this almost 200-year journey that we've been on as an industrialized society with refrigerants, and it really sets the stage for where we're headed next. Okay, so to back up for a minute, now that we've talked a little bit about our sector's journey through history with refrigerants, we need to define a few main terms and categories, because we've got to understand how the regulations and manufacturers think and talk about these substances. And there are a couple of main ways. The first one is based on their chemistry. And there are two broad categories, synthetic or natural refrigerants. Synthetic means that a chemical was created by people, invented by people, and created in a lab. It would not exist if it had not been invented and synthesized artificially in a lab. And going from left to right here, we're kind of marching through history. The earliest refrigerants, most famous of which is Freon, or CFCs, chlorofluorocarbons. And then we had HCFCs, hydrochlorofluorocarbons. These were what was phased out in the Montreal Protocol in 1987. And then to solve the problem of ozone depletion or ozone eating substances, the chemical industry came up with hydrofluorocarbons, who they don't have personalities. They're they're inanimate chemicals, but sometimes I think of them as having personalities. HFCs, or hydrofluorocarbons, do not deplete the ozone layer, but are still very efficient synthetic refrigerants. And then some of the newest classes of synthetic refrigerants that have been developed by big companies like Chemours and a few others are HFOs, hydrofluoroolefins. And we'll talk more about that in a minute. The other broad category of refrigerants is natural refrigerants. This means that these substances existed in nature before they were used as a refrigerant. No one's walking outside and grabbing a bunch of carbon dioxide out of the air and shoving it into a refrigerator. These things still have to be generated, in some cases, cleaned up, packaged, and pressurized in tanks for people to use them at the refrigerant grade level that they need them for, but they do occur in nature. And some of the super efficient natural refrigerants that exist that we can use now are so-called hydrocarbons, which just means that chemically speaking, they're made up of hydrogen and carbon. We've got carbon dioxide, ammonia, which has been used forever in industrial spaces. It is kind of its own animal. We're not going to talk about this much today because it's not used in residential heat pumps at the scale that this audience is most likely interested in. And then water and air are sometimes used as natural refrigerants. Again, not in residential heat pumps, sort of in industrial specialized applications, but there is a whole nother broad category of refrigerants aside from the patented synthetic refrigerants generated by the chemical industry, known as natural refrigerants. Okay, the next broad category that we've got to understand in conversations about refrigerants is their safety classification, which has to do with their effect on the human beings that handle them. It has nothing to do with the efficiency of these substances in carrying thermal energy. Has absolutely nothing to say about how, quote, good of a refrigerant a substance is. It's simply what effect would this have on a human being if they swallowed it or breathed it in or took it into their body in some other way. And ASHRAE, or the American Society of Heating, Refrigeration, and Air Conditioning Engineers, an old professional society in the United States, has set up this safety classification grid where across the bottom x-axis, you see toxicity going from non-toxic to toxic or poisonous. And then up the y-axis in the vertical direction, we've got non-flammable all the way up to highly flammable, where 1 is non-flammable, 3 is highly flammable. The hydrocarbon R290, which is propane, for example, is flammable. And many of the synthetic refrigerants, most of them, the older categories, are not flammable. And then a little while ago, a new category was introduced called A2L, which was meant to, or excuse me, 2L, which was meant to signify very slightly flammable, where technically you can light it on fire, but you got to work at it. So if a substance is in the A category, it's non-toxic. B, it's toxic. If it's a 1, it's non-flammable. If it's 3, it's highly flammable, or one of these in-between categories. So when people talk about refrigerants being an A1 or an A3 or an A2L or a B2L, this is what they're referring to, is this grid of safety categories. These don't have to represent a problem. It's not, none of these are banned based on their safety category. They just indicate what safety procedures kick in for the technologists, for the technicians who are working with the refrigerants at the time. So ASHRAE and other organizations have guidelines for how to work with various safety categories of refrigerants. So if you're working with an A2L or an A3 refrigerant, you have to make sure you're not creating sparks in the process of installing the heat pump. If you're working with a toxic refrigerant like ammonia, maybe in an industrial factory setting, there's a whole nother slew of safety categories that kicks in of just procedures that you follow to deal with them safely. Okay, so what do these things have to do with each other? Well, we've got our synthetic refrigerants across the top axis, or the top row of this slide, the synthetic refrigerants we talked about. CFCs, HFCs, which have been phased out, and HFCs are HFCs are by far the most common refrigerants in use today because they're so easy for technicians to work with, because they are in this A1 non-flammable, non-toxic category. With our drive to our efforts as a country, which we'll talk about more specifics in a minute, to drive down climate emissions from refrigerants, we are starting to have to shift into other categories because HFCs and the older ones have really, really high global warming potentials, which again, I'll talk about in a minute. They are thousands of times more potent than carbon dioxide at heating up the planet. So we've got to go to lower global warming potential, or GWP value, refrigerants, and that is going to push us into using, on the synthetic side of things, HFOs, and on the natural refrigerant side of things, hydrocarbons in the heat pump category. I put ammonia up here because you'll run into ammonia in the HVAC field. You're not going to in residential heat pumps for the most part. We're mostly talking about hydrocarbons when we're talking about natural refrigerants that work really efficiently in residential HVAC systems. So I'm going to back that back up one more time. We're going from A1 in the bottom left to either slightly flammable or flammable with hydrocarbons. Again, this doesn't have to be a problem. We know how to deal with this. We have super robust safety procedures and stuff in place. It's just a big change. It means that technicians will need to be familiar with slightly different procedures, not slightly, sometimes majorly different procedures, and that equipment that was designed for use with an A1 synthetic refrigerant cannot have a different safety category of refrigerant dropped into that system. New equipment will have to be installed. The old stuff will have to be torn out, including the line set copper piping that the refrigerant runs through, if someone is moving from an A1 to an A2L or an A3. These have very similar changes versus A1. Okay, so I've talked about all of this sort of in broad terms, but let's look at a super specific example. You can really see this trend of decreasing GWP with these newer categories of refrigerants as you move from a synthetic HFC and R410A, which is the most common refrigerant you may be familiar with now, that goes into residential ductless mini split heat pumps, for example. The newer technologies that are coming out on the market to try to lower this 2000 value of GWP are R32, R454B, and then R290, which is a hydrocarbon. And I put carbon dioxide up here for a reference. There aren't carbon dioxide residential ductless mini splits. They're water heaters and things like that. R744 is carbon dioxide, so its GWP value is 1. This is to show you that the reference for GWP is carbon dioxide. And whatever value a different refrigerant has for their GWP, it's a multiple of carbon dioxide. So this means that R410A, by far the most common refrigerant being used in residential ductless mini split heat pumps right now, it's a synthetic, has a GWP value of a little over 2,000. That means it is 2,000 times more potent than carbon dioxide if it leaks into the atmosphere. So what does that mean? Well, if 1 pound of R410A leaks into the environment in any way, is discharged end of life, beginning of life, during an installation, or through leaks, it has the impact on global warming that a ton of carbon dioxide has. So this is a picture I found online to try to help people visualize what a ton of carbon dioxide looks like. I think this is meant to be a bomb, and that's why there's that funny little orange thing up at the top. If you just look at this sphere with this guy standing here, that's a ton of carbon dioxide. And then you can try to imagine what 1 pound of R410A might look like. It's not big, right? And it's got the impact of volumetrically of like a building full of carbon dioxide. So this is why we're concerned about leaks and about the impacts of these refrigerants that are being used in technologies that people are installing in order to try to help the planet, right? So coming back again, just a reminder of our timeline. If you remember this is why the American Innovation and Manufacturing Act, the AIM Act, was passed by Congress, is to figure out a pathway for the United States to move away from leaking tons and tons of global warming potential of carbon dioxide equivalent into the atmosphere as we're trying to electrify. So the AIM Act, again, was passed in 2020 by a bipartisan Congress. And what it does is task the Environmental Protection Agency. The law tells the EPA, you have to do this. And what it says is it lays out a schedule to phase down the production and consumption of HFC refrigerants by certain dates on a schedule. And this is that schedule. So if you look along the bottom of this chart here, you've got 2022 up to 2039 on the far right, and up the y-axis, we're going from 0 to 100. And this table is just a different way that the EPA is illustrating that there are a series of phase down periods. And the law kicked in 2022, and with a 2-year phase down period, that was a 10% reduction from a baseline that was calculated based on data from 2012 and 2013 in the United States. Then there's a big step down that starts in 2024, and they have 5 years till 2029, the EPA, to reduce it by another 30%, which is tremendous. And then there'll be another tremendous step down in 2029 through 2033. And then in 2034 and 2036, there's some slight step downs to get us to an 85% reduction over time. They got to that number because the experts involved with drafting this is the schedule we've got to get on if we're going to drive down climate and emissions at a meaningful timescale in the United States. So how does this affect someone working in the HVAC industry? I'm not getting into the weeds on how this law works and the rules that the EPA is using to do this, but broadly speaking, there will be regulation and enforcement on the chemical industry side as far as how much of phased out refrigerants they're allowed to make. And then there are global warming potential ceilings, maximums for refrigerants that are allowed to be put in new equipment starting in 2024, 2025, 2026. For residential ductless mini splits, the deadline is going to be in January 2025, and the GWP ceiling is going to be 700, which is a good bit lower than our 410A, right? So this is why we're seeing these new products coming out on the market, is that manufacturers, original equipment manufacturers, OEMs, are responding to the next phase down deadline that's going to affect them. That's going to kick in 2025. And that's happening at the production and import level as far as what products will be available for installation in new equipment. So how does this affect someone working in this sector? Well, new equipment will be required to meet the phase down laws that I just mentioned. There are some details and caveats and loopholes that are being hammered out now, but broadly speaking, beginning in 2024, 2025, we're going to start seeing different types of new equipment being offered in order to meet the requirements of those phase down ceilings. And phased out refrigerants are going to get more expensive. And we know this because we've seen this before. After the Montreal Protocol, once the bans and phase downs of the ozone depletion substances were really able to kick in, some of you on the call may have seen this before, the price of older phased out refrigerants went up because the supply went down. So in old legacy systems, when people need a top up because of a leak, the price of that top up is going to get higher and higher as years go by. Okay, and with that, that is the end of the slides that I've got for you today. And I want to invite my colleague Li Ling, my friend Li Ling, to come on and talk to us about some more practical practices and tools that folks working in this area can implement. So I'm going to stop sharing so that she can share her screen and invite Li Ling to come on.
Thank you, Melissa, for a tour through history. One thing I want to add to what Melissa said is that the Montreal Protocol was very successful. The hole in the ozone layer is closing. The world got on the same page about the chemicals that were causing that. Some predictable things happened, including the success that we were after with the Montreal Protocol. And so going into the Kigali Amendment and the AIM Act, I think that we're really feeling like we can do this. Yeah. And since we've been around this block before, there's some predictability about what we're going to be up against, mostly in terms of cost. But I think that's good to keep in mind, is this is a process that can be successful. All right, so I'm going to really be focusing, in my mind, I'm going to be thinking about residential heat pumps. a lot of what Melissa is talking about and what I'm talking about does have applicability beyond the residential sphere, beyond heat pumps. Melissa mentioned a few times commercial applications. But most of my examples and a lot of what I'm thinking about when I talk about this is ductless heat pumps. And the reason for that is that there is a very rapid uptake of heat pumps in Vermont and across the country. Places like Efficiency Vermont, even in other states, they have their version of Efficiency Vermont, but also state goals are pushing heat pumps as part of an electrification effort to reduce the consumption of fossil fuels. And we have in Vermont have seen a big growth in the number of companies that are working with heat pumps. The other thing that I really love about the heat pump space is that there's the potential to get it right once and for all during installation. There is no reason that a heat pump system has to leak refrigerant. So going back to Melissa's comments about refrigerant stewardship, keeping it in the pipe is the best way to be responsible for refrigerants. And heat pumps, because they generally have few connections, have a really good chance of doing that if you install it right the first time. Okay, so back to the question, good for your business. Melissa and I talk to a lot of contractors, and we hear about the labor shortage, and we hear about how callbacks are profit killers. So we know callbacks are expensive, and we know that you want to avoid those. We are promoting what we call leak tight work because it is really one of the foundations of quality work. So, everybody wants to think of themselves as doing quality work. And we think that learning leak tight practices for installation and service is part of doing quality work. We're promoting a new class of tools that I'll talk about more. And for you all, I think that it's important to embrace that they can make your work faster. Back to the question about workforce, shortage in the workforce, and the need to bring new people into the industry to keep at the pace we're at now, but also to increase our pace because we'll need to do more heat pumps over time. We need ways to train up new technicians and to grow the industry, and most businesses are also looking to grow or at least to maintain the workforce that they have. And so how are we going to train new technicians? The tools that I'm going to talk about can make a green technician perform more like an experienced technician. We know that reclaimed refrigerants are going to become more expensive. I call it more valuable here because if you can avoid a leak, it means that you are saving your customer money, you're saving yourself time, and if it's a warranty call, you're saving yourself money too by not having to buy refrigerants that we anticipate will go up in cost. So leaks are going to become more expensive over time. If you can avoid leaks, it's better for your business. If you embrace the leak type practices that we will talk about today, it can be better for your business, better profitability, more productivity. So this is our pitch to you is this is good for you and your business. So I'm going to talk about refrigerant stewardship in these sort of stops along the way of the refrigerant journey, in the life of a refrigerant. So designing for few leaks, designing for good refrigerant stewardship, selecting the refrigerant that, the equipment that has the refrigerant in it that supports good refrigerant stewardship, good installation and service practices, diagnostics. So that's, how in the course of service, you look at, figuring out what might be wrong with the system. And then finally, tools for technicians. So most refrigerant systems are site-built. There are a few that aren't, but most are site-built. And so when we think about design and refrigerant stewardship, it's nice to consider what you can do at the design phase to reduce the number of connections that you're making on site, because site-built connections are vulnerable to errors and to leak. In this whole discussion, we're assuming that connections that are made in the factory are leak-free. That is something that is a working assumption of ours, but it's, it does bear being critical about that, because we've definitely heard about systems, perhaps some classes of equipment that are more vulnerable than others to leaks, on parts of the equipment that are built in the factory. So in any case, we're really promoting the idea that systems that have few on-site connections are better at leak reduction than ones that have a lot of on-site connections. And in many cases, especially for residential ductless heat pumps, it's probably more efficient also to have systems that have few on-site connections. So specifically what I'm talking about is a single zone heat pump versus a multi-zone heat pump. A multi-zone heat pump will have more connections. A single zone might just have 4 refrigerant connections. And if you want to serve more than one part of the building, perhaps a ducted heat pump, for instance, could serve more than one space and still just be a single zone heat pump. Individual heat pumps, they have a built-in leak limit. So, if you had a catastrophic leak with an individual heat pump, you're only going to leak the 1.5 pounds of refrigerant that's in that system. Whereas if you have a really big multi-zone system, like 60,000 BTU an hour heat pump, a catastrophic leak is going to result in a much bigger refrigerant release. And of course, there's VRVs, even bigger systems than what we're talking about in residential. And that's just really a risky combination, to have a lot of refrigerant connections and a large refrigerant charge. So if you only install ductless mini splits, it might feel like this little slide here is not for you, but making refrigerant connections in the field is not ideal. So if you have an option to do a factory sealed design, then that's going to be, better at leak reduction. But at a minimum, you're going to want to commit to perfect connections if you're doing on-site connections. So on the design question, if you are doing something like a monoblock system, which has all the refrigerant components in one unit and it's outdoors, then there are no on-site refrigerant connections to be made. And in that first column here, I have some examples of monoblock heat pumps. Now, these are all air-to-water heat pumps. But this would be a design decision that could be made that would eliminate on-site refrigerant connections and therefore eliminate the possibility of refrigerant leaks. And all the big manufacturers have monoblock designs. A ducted mini split, as I mentioned, is a way to serve, for instance, a whole building, but without all of the on-site connections that you would find in a multi-zone ductless heat pump scenario. And then on the right here, I'm showing a packaged heat pump, which in a way is like a monoblock system, but all the heat pump components are inside the building and there are no refrigerant connections to be made on site. So again, from a design standpoint, you can choose less vulnerability to refrigerant leaks. Okay, so now let's talk about refrigerant selection. Melissa already went through this, but even now, you have the option to choose heat pumps that are lower GWP, that use a lower GWP refrigerant. The one that I'm aware of is R32. Daikin has residential sized R32 heat pumps available right now off the shelf. So if you are installing R410A equipment, tomorrow you could start installing R32 equipment. I'm not aware of our 454B equipment that's available right now. And these other refrigerants, the naturals, are not, they're not in the residential HVAC market yet. Is that true? That's not true, actually. There are propane heat pumps for the residential market. Did you want to say something, Melissa?
Oh, I was just going to say, R454B, I don't know like a specific product, but I know we've heard that from specific OEMs that that's the direction they're going to go and they're going to have
Oh, for
products
sure. Right. Oh, and I
available
can
this year.
see here, I have a note with
And
this
propane
slide
too.
saying
Yeah,
Trane is developing products using R454B. I don't know whether they're on the market yet, but I know that there's R32 equipment that you can buy today and install today.
definitely propane because it's installed in Europe and Asia and other places.
Yeah. Okay, so now let's talk about installation and service practices. I think that probably what we're thinking about here is practices that the technicians are using every day. But I do think that the business practices are a really important part to consider here. And the tools that people use, technicians are using, are a big part of this too. So, as I said before, we have heavy emphasis on installation practices because a well-installed heat pump will never leak. And then at the end of its life, you have the opportunity to recover 100% of the refrigerant. So that is great refrigerant stewardship. But the business practices we are hearing from trainers and from contractors, that business practices are as important, maybe more important than all the rest of this. And I'll talk more about that, but actually, I'm not sure whether I have another slide to talk about that. So let me just say here that examples of business practices that will support good refrigerant stewardship are things like how do you arrange for continuous training of your technicians? If you employ technicians and you feel like they're going to arrive knowing their job, and it's not your job as a business owner to continually train them, I don't think that's good refrigerant stewardship. Everybody needs to brush up their skills, and we want technicians to get better and better, also faster and faster at their work. So have a plan for ongoing training of your technicians. Within businesses, there needs to be an effective feedback mechanism from the service side of the company to the installation side of the company, because the installers need to know if they're doing something that is resulting in a refrigerant leak, but also just in something that is going to cost the business money down the line due to a callback. They need to know that so they can alter their practices during installations. If you don't have good feedback between those two sides of the business, then I think it's really hurting the business, but also obviously setting up an opportunity for refrigerant leaks. There's another business practice. Who owns the tools? In many HVAC companies, like with carpenters, the technicians are expected to own their own tools. And if that's the case, oftentimes we find that technicians don't have the latest tools and don't feel like they can afford to buy the best tools that are going to allow them to do the fastest, most high quality work. What if the company owned the tools? Or what if a company provided a tool allowance every year to make sure that the technicians have a chance to upgrade their tools? And then really what we're hearing is a very difficult thing for businesses is management of recovery tanks and how you return refrigerants to a place that's going to recycle the refrigerants. We know it's a problem. We know that the industry has to become better at making it easier to do that, but within companies, also having good management of your refrigerant recovery, or at least having a relationship with somebody who you can hire to come in and do refrigerant recovery. That's a business practice that's not on the technicians, but it's really important for keeping refrigerants from being released. So as for the technical practices, we have hear consistently about the worst. Like, everybody knows about what the worst things are that happen out there. For the way that we look at it, things that are, really among the worst are like the gas and go approach, which is like, you've been to this system before, It's always low in refrigerant every time you go there. You don't know where the leak is, but you just fill it up with refrigerant and go on your way. And you're going to do it again in 2 years. That is really a bad practice. And there are, let me just say that in the future, Efficiency Vermont hopes to have trainings to help you do better there. So another kind of, not good practice is during installation, not understanding whether the refrigerant lines are leaky or wet. It can look the same thing. If you don't have really sensitive gauges, it can be confusing to know whether you're still dehydrating the lines or maybe there's actually a leak. Poorly formed flares. It's surprising to me to hear that many technicians still don't have a torque wrench. So, have poorly formed flares or not tightening flares to the right tightness, not doing bubble testing during pressure testing, maybe not even pressure testing at all during installation, not removing the valve cores during evacuation. So we already know that the worst practices are sort of endemic in the industry. But the best practices, they're not a mystery. They're pretty basic. They're not always adhered to, but they're well understood at least. So protecting line sets from air and moisture, really important. Purging with nitrogen and doing the pressure test. And in the course of all that, understanding what the maximum pressure is that the system can tolerate. Doing leak testing with bubbles or an ultrasonic leak detector. So both bubbles and an ultrasonic leak detector do not require refrigerant to be in the system. When pulling vacuum on a new system or even a system that has been serviced, remove the Schrader valve core. Deep vacuum to clear out the pipes, make sure that they're completely dehydrated and ready for refrigerant lease. So those best practices, along with the practices that avoid refrigerant lease during service, they're not, there's nothing exotic there. It's basic quality work. Okay, going on to diagnostics here. So diagnostics is now like in everybody's pocket. All of these companies and more, they make a diagnostic app that you can download onto an iPad or onto your phone that you can have on the job site with you. You can see that some of these companies here are manufacturers of tools. So let's see, Testo, they make tools. Yellow Jacket, they make tools. I don't even know what all of these little symbols are here, but a lot of these are tool manufacturers. On the right here, MQ is Measure Quick, and they do not make tools, but that is a diagnostic app that connects to any of the Bluetooth tools that all of these other manufacturers make. So that's the diagnostic app that sort of unites everything. And I just learned this week about another one, which is called Visual Service, that also will work with any Bluetooth tool. So having tools that communicate and then having the diagnostic app with you on site is one of the things that is going to just bring all of the benefits of leak tight work right to your company. It makes your work go faster. It confirms whether or not you have quality installation. You can create reports out of these tools so you can give those to the homeowner, or you can store those reports for your own records so that if you ever have to go back to that system, you know what the charge was and what the pressures were. And so all of these really can change the nature of how you do work, but also contribute to good refrigerant stewardship. So this is just a blog I found from Train. They, are making this very direct connection between, here it says technology, but what this blog was really about was about new tools, communications between tools and, the cloud. And so they're saying these new tools, these new technologies can help solve the HVAC labor issue. So here's Train saying we have these new capabilities with these new technologies, and that's going to be the thing that saves us with our workforce problems. And we believe that too. I mean, we think that having better tools makes new technicians better technicians. All right, so here are the tools that I'm talking about. These are the tools that I consider essential for leak tight work. I show some pictures up here, but I just want to be clear, I'm totally brand neutral. Tools that are highly accurate and have the ability to communicate, those are the tools I want. It doesn't matter to me whether it's made by Fieldpiece or Navac or Appian. All these communicating tools are equal in my mind. So don't take these pictures as endorsements of any particular brand. Okay, so on the upper left, we have a digital manifold. It's much more sensitive to changes in pressure, which means it can calculate, for instance, the pressure decay during a pressure test, rather than waiting an hour to see what the pressure has done over the course of an hour or 5 hours. You can just calculate what the decay rate is, in the course of a minute. So it can really speed up work in that way. In the center on the top there, the two orange tools, that is a powered eccentric flaring tool with a depth stop that makes a perfect flare every time, and then a torque wrench. These two we have heard repeatedly is the core tools for improving the quality of work. I mean, I think all the rest of these tools are important too, but at a minimum, you need to have a good flaring tool with a depth stop and then use a torque wrench every time. On the upper right, we have, this is a refrigerant sniffer, a leak detector. It is infrared, and it can be used with flammable refrigerants. And some tools, some refrigerant sniffers cannot. So this is, the beginning of the introduction of what Melissa already referred to, which is you're probably going to have to retool for the coming A2L refrigerants. Recall that R410A is not going to be available in new equipment pretty shortly, and the supply of R410A is going to be diminished over time. So you will be working with flammable, slightly flammable refrigerants pretty shortly. So you're going to have to retool for that. Okay, so on the lower row of photos here, we've got a digital micron gauge. So this is for pulling a vacuum on the system. It's very easy with this kind of device, so highly accurate. It's communicating with an app. It's easy to tell whether you have any moisture in your refrigerant lines, or perhaps there's a teeny little leak. And you can do that because the shape of the pressure decay will be different with moisture in the system versus a tiny little leak. And you would never be able to detect that by just looking at a gauge, but when you have the diagnostic app, it can show you. And so rather than doing triple evacuation, you can use this to do a single evacuation and know, yes or no, are the pipes still wet? Okay, if they're still wet, then sure, you need to maybe do a triple evacuation. But if the pipes are not wet, you can go on your way in 5 minutes. Okay, in the center there, on the bottom, we have a recovery machine that is rated for flammable refrigerants, and then a scale that actually also communicates with these cool diagnostic apps. So you can record how much refrigerant you have recovered right into the cloud. And then a lower right, low loss fitting. So when you're doing service, if you have to attach gauges to a refrigerant loop that has refrigerant in it, you want to use, I call them gauges. These are low loss fittings. You want to use fittings that are not going to let a little bit of refrigerant out every time you attach a gauge. All right, so the DOE, the Department of Energy, has something that they're calling the STEP campaign, which is promoting the very tools that I just showed you, these high accuracy communicating tools used with a diagnostic app. And this is just a case study of a contractor that converted to using these tools. And here's a quote in the upper right from this contractor saying, "My technicians tell me all the time how these tools have made it easier to do their jobs. They don't have to fumble around trying to document information. They take less time at each job site, and they can use data to justify recommendations to customers." So there are people besides us that are promoting the use of these tools and really feel like, again, that they're going to make new technicians better, faster, and they're going to save companies money and time. All right, so I'm getting to the end here. I want to tell you that Melissa and I are, we have a very small pilot going where we are promoting the use of these tools. We have a set of tools to lend out. We are looking for contractors to work with to help us understand how the tools impact your work. If you are interested in working with us through that pilot, please contact Melissa or myself at Efficiency Vermont. You can just call the Efficiency Vermont line. I think on the last slide here, I might have our email addresses. But also coming up next year, very shortly here, is we're going to have a series of HVAC trainings intended to help contractors and technicians convert to what Melissa and I have been talking about here, which is use of tools to do better refrigerant management with your technical work, learn how to use the apps, also understand what's coming with the A2L transition. One of the things that's not shown on this list is we're inviting ACA, the Air Conditioning Contractors Association, to come and give an A2L. So we recall that A2L is flammable refrigerants, or slightly flammable refrigerants, an A2L training. You should plan that you probably will have to go through a safety training with the manufacturer of your choice when they start selling R454B or R32 equipment. And you know, all of these trainings will also support you in learning about the new techniques that you'll have to use with the flammable or slightly flammable refrigerants. So we will, these trainings are going to be offered through the Efficiency Vermont Efficiency Excellence Network, the EEN, the same network that's putting on this training. These trainings go out, and I think in announcements, and of course you can find them on the Efficiency Vermont website, and they'll be recorded. So I think something that I wanted to say with this slide on tools that I didn't say, and that I just want to say in conjunction with these trainings that we're giving going forward, is starting now, every new tool that you buy or that you have a technician buy for their work needs to be A2L compatible. And Melissa mentioned this in passing, but all of the equipment and tools that are used with flammable refrigerants, whether they are slightly flammable, the A2L refrigerants, or highly flammable, the A3 refrigerants, they need to be certified for use with flammable refrigerants. Everything I'm showing on the screen here is certified for use, but what we have found is that the local supply houses don't know how to identify tools that are for use with flammable refrigerants. And I'm not really sure how to get around that. I would say you can call Melissa or myself and we can sort of help you if you are looking to retool in a big way. But coming pretty, like right now would be a very bad time to buy a tool that is not A2L compatible, because it's just money wasted, since you won't be able to use it on all the equipment you're working on in pretty short order. Like, you know, maybe starting tomorrow, you might install an R32 equipment, R32 heat pump, and then you'll have a tool that you can only use on R410A, but then you can't use on the new heat pump that you just installed. So don't go with old tools anymore. It's time to buy new A2L compatible tools. All right, so that's part of what we'll go over through all these trainings. So that's the end of my section. And here, yes, so here's the contact information for Melissa and myself. I'm not going to stop sharing my screen because I want people to be able to write this down if they want those emails. But Bryn, are there any questions in the chat? Maybe Melissa,
no.
you can come back on screen.
Nope, we don't have any questions right now. Definitely covered a lot of ground. Really, really helpful information. I don't know, I guess if there's anything else that you'd want to note or wrap up, or just about at time.
And also, maybe we can just invite, I see that there's 2 participants. We can invite them to unmute if you just want to have a discussion. Sean, is there anything that you want to ask or add to this? And then,
No, not so much. Definitely want to say thank you again because I'm definitely part of the tool program there and can say for sure that it does make the installs faster, which is great. And the peace of mind with the tools, just knowing that everything's nice and tight has been great. So thank you again.
good. And then there's one other attendee. Is there any, I'm not sure how to see that person's name, but
Alex?
anything else from
Alex.
Alex?
Yeah.
No, I was just appreciated the presentation. You know, back when BBD first started, I was still fairly new, and it's nice to see this again and understand what you guys are talking about to a greater extent. So thank you.
Oh, right. You saw the first time Melissa and I gave this presentation.
Yeah, I was only like a month in at that point, so I was kind of trying to get my bearings.
Well, thanks for joining us again. Maybe more of it stuck. We did
Oh, yeah.
cover a lot of ground. That's true. I guess since we just have not many questions here, I want to add one other thing that I noted in Melissa's section. Melissa, you said that refrigerant piping also will not be able to be reused with the new refrigerants. And I have heard, I think this is one of the evolving parts of this transition is people better understanding what's going to be possible with the new refrigerants. For instance, both R32 and R454B, they operate at a similar pressure as R410A. So that's something that technicians will, be gratified to know.
Yeah.
But the other thing that I learned recently is that many manufacturers, some manufacturers, I should say, are saying that R32 systems can reuse R410A refrigerant lines if the technician is confident that there was no damage to the lines. Like, if the last installation was bad and there was maybe like moisture in the system and there was a breakdown of the oils and the refrigerant in the old system, you may not want to reuse refrigerant lines. But they're saying because R32 is a component of R410A and you can clean out the line set, if you can clean out the line set, you can reuse the line set. It has to be the right size for the new equipment.
Right.
And as I said, you may not want to because you may not be aware of really what the history of that line set is. So there's a lot of stuff that's not known right now about what this transition is going to look like. But that's one thing that I have heard recently that surprised me is some manufacturers are saying you might be able to reuse the line set for R32.
If we end up presenting this content again, I'll update that or omit that part. Yeah, it's ever evolving, definitely.
Melissa, thank you so much for saying that.
It was in October,
Okay, so let's see. Bryn mentioned something here about we have a new conference coming up in April of next year, and Melissa and I are going to present again on this topic then. However, we're going to have a totally different focus, which is really going to be on preparing your company for the transition. So understanding things like what is the likely price trajectory of refrigerants? What are you going to have to know from the manufacturer of the heat pumps that you install? So we're going to revisit this at Better Buildings in 2024. We hope that you come to the conference. And I think that even if you've attended this twice, the way Alex has, I still think there's going to be something in our new session that you're really going to want to hear.
Awesome. Thank you so much for your presentation today, for making this available as an online webinar. I know it has great value, not just today, but for other folks that will watch it in the future.